let's look at this will be chapter 4, topic 1, day 1. Topic 1, day 1. That's pretty bad. Let's try that again. Chapter 4, topic 1, day 1. Alright, so what we're going to be looking at in chapter 4 are quadratics. Quadratics are a type of function where the degree of the function is 2. So you see here we have a x squared term. That means that the degree, and that's the highest exponent, so the degree of this function is 2. So it's a second degree polynomial, which means that it is a quadratic, which means when you graph it, it's going to be a parabola, which just looks like a U. Alright, it looks like a U shape. It's mirrored over the center, so if you draw a line through it, it should be mirrored through that line, and the point in the very middle where it's mirrored right here is the absolute lowest point, and this is called the vertex. What we're going to be looking at today is how do we actually use the equation to graph the parabola. And the standard form of a quadratic equation, y is equal to ax squared, so a is the coefficient on x squared, plus bx, b is the coefficient on x, plus c, c is the constant. Alright, here are all the steps necessary to graph a parabola. Determine if it opens up or down. So that would mean, does it look like this, or is it in the other direction like this? If the A is positive, then it's this one. If the A is negative, then it's this one. We find the x value of the vertex by using this formula. X equals negative b over 2a. B and a come from the equation, or from the quadratic equation. And then whatever that value is, we substitute it into the equation to find the y value. And what that will give us is the ordered pair for the vertex. It will give us the x value and the y value for the vertex. So we'll have the ordered pair for the vertex. The equation for the axis of symmetry. The axis of symmetry, remember, if a quadratic looks like this, and the vertex is the lowest point right here, then this imaginary line where the quadratic is reflected, the left side and right side look the same, that is called the axis of symmetry. It's where the parabola is symmetrical. And the equation for that is a vertical line, so it's x equals some number. Then we find the y-intercept. The y-intercept has an x-coordinate of 0 and a y-coordinate of c, whatever c is. Now remember, this a, b, and c is coming from the equation ax squared plus bx plus c. So the c value, which is the constant, that's the y-coordinate of the y-intercept, and 0 is the x-coordinate. If the graph opens up like this, it will have a minimum, and if it opens down like this, it will have a maximum. Then we take that y-intercept, whatever it might be, and we'll reflect it across the axis of symmetry to get another point on the opposite side of the axis of symmetry. And we state the domain and range. So let's see what this looks like in practice. So if y is equal to x squared minus 4x plus 0, okay, because there's nothing over here. So we first identify our a, our b, and our c. Our a is the coefficient on the x squared term. So there's nothing there, so that would be a 1. So a is 1. B is the coefficient on the x term, so that's negative 4. and c is the constant, which here is 0. Since our a value is positive, it's 1, this will open up. So it's going to look like this. It's going to look like a U. Alright, so we're looking for the vertex next. So we need to use the equation x is equal to negative b over 2a. And this will give us the x-coordinate of the vertex. So we just substitute the b and a from the equation into this formula. So negative b is negative 4, so that would be positive 4. And then 2a is 1, so that would be 2. 2 times a, 2 times 1. And 4 divided by 2 is 2. So the x-coordinate of our vertex is 2. To find the y-coordinate, we go to the original equation and we substitute 2 into the x. So we have y is equal to 2 squared minus 4 times 2, and then plus 0. You don't have to include the plus 0, but we have it, so we'll include it. So 2 squared is 4. 4 times 2 is 8. 4 minus 8 plus 0 is negative 4. So when we substitute in the x-coordinate into the equation, we get negative 4. So the y-coordinate is negative 4. So our vertex will be at 2, negative 4. And that vertex will be a minimum since this one opens up, and it'll be at the very bottom. So that vertex, which will be at the bottom, is a minimum. The axis of symmetry is a vertical line. So it has the equation x is equal to, and it's going to be 2. It's going to be the x-coordinate of the vertex. So it's going to be x is equal to 2. The y-intercept always has an x-coordinate of 0 because it's on the y-axis. And the y-coordinate is just the c value, which we determined was 0. So it's going to be 0, 0. Alright, we will graph this now, and then after we graph it, we'll determine our domain and range. So let's erase some of the, oops, I erased my C. That's okay, I don't really need it anymore. Alright, so here's the order that we're going to do for graphing. We're going to graph the axis of symmetry first, followed by the vertex. After we graph the vertex, we're going to graph the y-intercept. After we graph the y-intercept, we're going to reflect the y-intercept. After we reflect the y-intercept, we're going to draw the parabola. So these are the steps: axis of symmetry, vertex, the y-intercept, reflect the y-intercept, and then draw the parabola. So let me start with the axis of symmetry. The axis of symmetry is x equals 2. So that is a vertical line that goes through 2, and we're going to draw it dashed because it's not really there. It's imaginary. It's only there to help us create the parabola. So the axis of symmetry is first. All right, I'll check that off. The vertex is next, so 2, negative 4. That's going to be right here, so I'll put a dot there, a point. So I'll check that off. My y-intercept is 0, 0. So that's right here. Alright, 0, 0 is right here. Okay, this is 2, negative 4. And this is 0, 0. Alright, so I got the y-intercept. Now, I'm going to take the y-intercept and I'm going to reflect it across the axis of symmetry. So what that means is it's 2 spaces away. 1, 2. It's 2 spaces away from the axis of symmetry. So on the other side, I'm going to put it 2 spaces away in the other direction, over here. And that ends up being the point for 0. Okay, so I reflected the point. All I have left now is to actually draw the parabola. Remember, it should look something like this. It should look like a U shape. So I'm going to pick a color. Let's go with, I really want purple. All right. And I'm going to trace a parabola. It doesn't have to be perfect. It just needs to look something like a parabola. All right, yours will probably be better than mine because I'm trying to do this on my drawing tablet. All right, so something like this. All right, so something like that. That would be our parabola. That's the shape of our graph. That's the equation. Y is equal to x squared minus 4x. Okay, that's the graph for this equation. The domain is all of the possible x values. So if we follow the x-axis, this graph actually goes all the way on the x-axis to the left and all the way on the x-axis to the right. The arrows mean that it just keeps going. And this will be true for every quadratic. Every quadratic has the same domain, negative infinity to infinity, or all real numbers. All right, either one of these are fine, negative infinity to infinity, or all real numbers, and infinities use parentheses for their interval. So remember, this is an interval. It says that the minimum of the x values is negative infinity, and the maximum of the x values is positive infinity. So that's the interval for the domain. The range is a little bit different. The range follows the y-axis. If we look at the y-axis, and we look at the graph in comparison to the y-axis, we see that even though the graph completely goes up, it doesn't completely go down. It starts at negative 4, and it goes up from negative 4. So the minimum would be negative 4, and anytime we use a number like this, we use a bracket, because that's a solid point there. Negative 4 is included in the range. So it's going to be negative 4 is the minimum, starts at negative 4, and it goes up to infinity. So the range would be negative 4 to infinity. And that would be our graph. All right, example number 2. This is written in function notation. Okay, you can pretend that this says y is equal to negative x squared plus 6x minus 8. Okay, f of x is the same thing as y, essentially. All right, we have to identify a, b, and c. A is the coefficient on the x squared term, which in this case is negative 1. B is the coefficient on the x term, which in this case is 6. And c is the constant, which is negative 8. Since the a value is negative, this opens down. It's going to look like this. The vertex is going to be up here. And speaking of the vertex, same way, we need to find the x-coordinate of the vertex first. So we're going to use the formula negative b over 2a. So b was 6, so we have negative 6. And then 2 times a is negative 1, so that's going to be negative 2. And negative 6 divided by negative 2 is 3. So the x-coordinate of the vertex is 3. We do need the y-coordinate of the vertex. So we are going to substitute into the equation 3 for x. So we have negative x squared, so that's negative 3 squared, plus 6 times x, so 6 times 3, minus 8. 3 squared is 9, so that's negative 9, plus 18, minus 8. Negative 9 plus 18 is 9, minus 8 is 1. So the y-coordinate of the vertex is 1. We made a sketch here, so we can see that the vertex is actually a maximum here because it's at the very top. And then remember how we find the axis of symmetry. We just look at the x-coordinate of the vertex, which in this case it was 3. So our axis of symmetry is a vertical line, x is equal to 3. The y-intercept always starts with 0, and then the y-coordinate is the c value, so 0, -8. You can see that if you plug in 0, this term disappears, and so does this one. All that's left is the -8. So now I can graph this. Start with the axis of symmetry, then the vertex. Whoops. Then the y-intercept. Then you reflect it. And then you draw. You draw the parabola. Alright, so the first thing I will start with is the axis of symmetry. It's at x is equal to 3, so I'm going to put a little dashed imaginary line. This is different than an inequality, okay? This isn't an inequality, it's just an imaginary line. So the axis of symmetry, check. Next, I will do the vertex. So the vertex is at 3, 1, that's right here. Check. It's the ordered pair 3, 1. Next, I will do the y-intercept, which is at 0, -8, so that's right here. So I put the y-intercept, 0, -8. Alright, check. I'll now reflect it to get another point, so I gotta count how far away it is from the axis of symmetry. So 1, 2, 3. So I'll go 1, 2, 3 in the other direction. So check, I've reflected it. Now, last but not least, I need to draw my parabola. Keep in mind, it's going to look upside down, so it will look something like this. It should go through the point. That was kind of my mistake there. Missed it by a smidge. There we go. Go. All right. Not the best, but you know, it is what it is. And then we do the domain and range. So we drew it, and we got to do the domain and range. Just like the previous problem, the domain is -infinity to infinity because the x-axis, it goes all the way left, all the way right. So there is no boundaries for the domain. For the range, however, it starts from -infinity, and then it goes all the way up to 1. You can see that the highest that this graph goes is at the vertex 1. So we would say that this is from -infinity all the way up to 1. We use a bracket on the 1 and a parentheses on the -infinity. And here is the assignment. For number 2, you will need to renumber the y-axis and go up and down by 2's instead of what I assume is 1's.